Virtual reality games can well elicit the physiological responses. Then it can be used developing treatments in healthcare domain. In this study, we carried out exploratory physiological data analysis to find most responsive physiological data and wearable sensory device feasibility for the responses of fear. We used off-the-shelf commercial horror survival game Life-Alyx to provoke fear emotion. The game's detailed graphics, well-designed environments, suspenseful pacing, and encounters with terrifying creatures like headcrabs contribute to a fearful atmosphere. We used Empatica wristband, Polar H10 chest strap, and HMD as sensory devices to capture the physiological data. Basically, we investigated the classification of 3 levels of fear emotion, which was provided by PANAS-X questionnaire as subjective feedback. Firstly, we pre-processed each signal and extracted 4 different features for 10 different physiological data as input for deep learning algorithms. We used 4 from-scratch deep learning models such as LSTM, bidirectional LSTM, CNN-LSTM hybrid model, and transformer to classify 3 levels of fear. Additionally, we conducted a time window analysis by segmenting the data into 10, 20, and 40 seconds of time intervals to explore the temporal significance of deep features on the learning capacity of the models. To find optimal hyperparameters for each model type, we conducted a grid search covering different model configurations, resulting in 1,600 total training of models. After training, we initially applied our classification models to individual sensory data. The electrocardiogram data stood out as the most reliable signal, achieving 82% accuracy and 80% F1 score in fear stimuli recognition in our study. The transformer model self-attention mechanism demonstrated a remarkable ability to interpret heart rate variability, R waves interval, and other parameters reflecting autonomic nervous system activity. Accelerometer emerged as the second best signal for fear recognition, with bodily movements contributing to recognizing expressions of fear. Player-specific movements, such as shooting and coping with enemies, exhibited distinct patterns, enabling the models to identify fear. Subsequently, we conducted a sensory-based performance analysis using all physiological data from each sensor. The results shows that Polar H10 chest strap sensory device is feasible for considerably robust for fear classification tasks and preferably instead of complex electrode-based devices like EEG. For more details, please refer to our paper. Thank you.